Today we're going to focus on, instead of these first four, we are going to focus on the next three. So numbers 5, 6, and 7. This is one of the most important formulas in trigonometry that you can learn. And I don't know if you remember it, but we've covered it before. Sine squared plus cosine squared is 1. We've covered it. Okay? Now, I'm going to do something to change this up a little bit. I'm going to subtract sine squared from both sides. And I get a new formula. Cosine squared is equal to 1 minus sine squared. You see that? So not only do I have this first formula, I have a second one. You know what I've done? I've written them right over here for you guys. In fact, if you subtract a cosine squared from each side, you get a sine squared of x is equal to 1 minus cosine squared of x, which you see is sitting right there. We're not really going to focus so much on the lower two. We'll talk about that later. But for today, we need to recognize that we have sine squared plus cosine squared is 1, which can also be written those two ways. Furthermore, you have 1 plus tangent squared is secant squared, and that can be written those two ways. And we have 1 plus cotangent squared is cosecant squared, and that can be written those two ways. Here's the idea. If you have something squared and a 1, there's a good chance that it's on that page somewhere. Agreed? So, keeping that in mind, let's look at some of these problems. We start with letter L. We have 1 minus cosecant squared, or cosine squared times cosecant. Doesn't look like a very fun problem. And your first inkling might be, let's change it all to terms of sine and cosine. Not yet. Because I see this. And I see that 1 minus cosine squared can be rewritten. Do you see something on your sheet of paper that says what 1 minus cosine squared is? It's sine squared. It says it right here. Now, I can't find this for you on the test. All I can do is give you the sheet of paper, and hopefully you're able to reference that if you see a 1 and a cosine squared, that you're probably looking at section 5. And if you look over here, you see the 1 minus cosine squared, sure enough, is sine squared. So I'm going to take this, and instead of writing it 1 minus cosine squared, I'll write a sine squared. That's what I'm going to simplify now. That is very similar to what we did yesterday, right? Do I have to rewrite sine squared? No, I'll just write sine squared over 1. Should I rewrite cosecant? What does cosecant get rewritten as? Times 1 over sine. What will cancel? One of the sines. Yeah, this is sine times sine. So you have one of the sines cancel, and that will leave you with just sine of theta. See that? So what we want to do today is recognize certain relationships that we could substitute in, and then do what we did yesterday. See if you could try M on your own. Okay, give M a shot. Can I ask what you substituted in for secant squared minus 1? Tangent squared. So if I see a secant squared and a 1, my eyes are drawn right away to number 6. It has a secant squared and has a 1. And this says secant squared minus 1 is tangent squared. So that's my substitution. So instead of writing that, I write tangent squared. That looks like a problem from yesterday, doesn't it? I don't rewrite cosine squared, but I do rewrite tangent squared. How do you rewrite tangent squared? Sine squared over cosine squared. And as you notice, the cosine squareds will cancel out, leaving with a sine squared. Okay, letter N is very similar. I have a secant squared minus 1. We saw that in the previous problem. What should I put in for the secant squared minus 1? Tangent squared. That one little substitution now puts us in a situation like we were yesterday. How should I rewrite tangent squared? Sine squared over cosine squared over what? Sine squared over 1. So I am dividing. Instead of dividing, I should multiply by the reciprocal, and the reciprocal is 1 over sine squared. What happens? Sine squareds go away. I'm left with 1 over cosine squared. Can I rewrite 1 over cosine squared? Secant squared. Some of you are finding that you actually kind of dig this stuff. It's another word for like. I don't know if you're up with the times. Emily, don't shake your head at me. Okay, Ian is laughing. He's laughing so hard he's going to vomit here, I can tell. Okay, yeah. But Andy likes it. It's connecting with his brain, isn't it? Yeah. With the note sheet, it's easier, isn't it? So we'll give Andy a challenge. Andy, try it without the note sheet. Okay, all right. No, don't want to do it. All right. So, all right. What makes O different? We have some multiplication. In fact, if you rewrite that tangent squared as sine squared over cosine squared, nothing good is going to happen. So don't write this down, but I'll show you what a lot of you would like to try to do. Number one, some of you will do this. You'll just cross off the tangent squareds. That's totally illegal. Okay, totally illegal. You get 0 points on the test for that. Okay, you can't do that because multiplication comes before subtraction. Okay, so you might say, well, this is sine squared of theta over cosine squared of theta minus sine squared of theta over cosine squared of theta times sine squared of theta over 1. And you see, oh, nothing cancels. You get a sine to the 4th. Nothing good happens, folks. Anybody see what to do? Somebody be the genius and see the trick to the problem. You have to do something that I taught you how to do. It starts with an F. Rhymes with actor. Factor, very good. We are going to factor out a common factor. Now watch. Every year I do this, some people get a little bit confused. We'll show you this. If I have x squared minus x squared times y squared, what is the common factor that these both share? An x squared, right? If you take an x squared out of this, what's left? What's left here? A 1 minus a y squared, right? That's how this factors. Agreed? So what do these share in common? A tangent squared they share in common. When you take it out, what are you left with here? 1 minus, what are you left with here? Sine squared. So a little factoring gave us a 1 minus a sine squared. Well, I like that. That's on my sheet, right? What is 1 minus sine squared? It is cosine squared. Well, now I'm home free, because that's a problem like we just did yesterday, and Mr. Gens had us do a checkpoint on that, and I'm pretty confident we all know how to do that now. So we'll rewrite tangent squared as sine squared over cosine squared times cosine squared over 1. Cosine squareds cancel, and I'm left with sine squared. Now, some of you are saying, well, Mr. Gens, I just crossed off the tangent squareds, and I got sine squared anyway. You just got lucky, okay? Doesn't really work like that most of the time, all right? Let's try another one. Let's try P. Another problem that involves factoring. What should I factor out? Sine squared. What's left? Yep, what's left there is secant squared. What's left there? What is secant squared minus 1? Is that something on our sheet? It is tangent squared. Now, let's think about rewriting this. How do you rewrite tangent squared? Is sine squared on the top or the bottom? The top. So are the sine squares going to cancel? They're not. So this is it. If it was cotangent squared, then the sine squared would be in the denominator, and they would cancel. I will be pretty lenient on your test. If I see you get to this, I probably won't take points off if you try to go farther. But again, so if you wrote as sine squared of theta over 1 times sine squared of theta over cosine squared, you would end up writing sine to the 4th over cosine squared. And I don't think that that's any better than this. Nothing cancels. So I would like you to see that and then hopefully cross it off and circle that or box that. One last problem. What factors out? Cosine squared of theta. When I factor it out, what's left here? 1 plus Thank you for asking the question. There is a 1 in front of tangent. But let's just think about it. If you were to distribute this through, cosine squared times 1 is cosine squared. Cosine squared times tangent squared is cosine squared tangent squared. So that gives me exactly what I have here, right? So it doesn't disappear. There's a 1 in front of there. But that's why we end up with 1 plus tangent squared. Is that better? What is 1 plus tangent squared? I think that's on the sheet somewhere, isn't it? I think it's number 6. Yeah, sometimes you get so used to looking over to the right-hand side that you forget to look at these exact identities. So 1 plus tangent squared is secant squared. Oh, is it getting mad at me? Come on. Yep, now it's angry. Smartboard got dumb. Okay, green. All right, so 1 plus tangent squared is secant squared. I use that. I go back here. Now, I'm going to write this out, but I want you to know that some of you will skip this step. Do you know the relationship between cosine and secant? They are reciprocals. And when you multiply two reciprocals, what do you get? 1. So some people will just say this is 1, and that's fine. If you wanted to write it out, cosine squared of theta over 1 times 1 over cosine squared of theta, you would see that the cosine squareds do cancel, and I get 1. So whether or not you choose to write that out, I would give you that credit. So again, you must make sure that you're showing your work and your steps. I don't give credit for just guessing. You must show these pieces through. So again, I would say that these are more like level 2 type problems. Tomorrow we want to get to the more difficult ones, okay? And we'll get a day to review in here and a day of practice as well, excuse me, and you'll be good to go. So let's have a short assignment again. Okay, it looks like a lot because I wrote a lot of problems, but it's really only 10 problems. We did, I mean, between the checkpoint and everything, we did 8 in class already today. So you could get for sure half of your assignment done before the hour is over, I think. So I'll give it a shot.